Hi everyone, hope all of you are safe and are doing good. I am Tanisha, and today I'm going to talk about the W's of React. So, I feel this is more of a lot of my personal experience because when I started out with React, I was too overwhelmed with the hype around it, with how the coding was done, how we shifted from HTML and CSS to all these libraries and frameworks, and I straight up jumped to coding. And what was my main mistake was I did not understand that why this thing exists and what problem does it solve. So I feel everything has two questions, what and why. In the sense, what problem does it solve and why does this thing exist? I did not uh, answer to these questions when I was starting out. And eventually, what I had to do is go back again, read about it, understand how React is doing what it is doing, and why certain things are coming up with React. For all of you who are starting out with React, don't straight up jump to building something. First understand, try on little by little, and so this talk will give you a quick overview of how things are happening a little in the background and how some things exist right now in the React domain. Before the libraries and frameworks boomed in, all we had were HTML, CSS, and JavaScript. There was nothing more, there was nothing less. Obviously, right now there are refined forms of the same. The bases remain the same because even in React app, you type something called JSX, which is HTML and JavaScript, and CSS for styling. This was the whole picture. Don't mind the broken arm of the CSS. So I hope that's how CSS codes are, at least mine is. But anyway, moving on. How these things came together to do something was called the critical rendering path. So, for those of you who are hearing this word for the first time, don't worry, my reaction was the same like, whoa, what is this? But it isn't that complicated. So, critical rendering path is a sequence of steps that your browser adopts to bring in all the HTML, CSS, and JavaScript files to display your web page on the screen. So as I said, it's a sequence of steps. So let me just quickly walk you through those steps. So the first step includes the creation of the DOM. The document object model is a fully parsed HTML page. By that, I mean that all the HTML tags that you've written in your file, they are constructed into a tree-like structure. So all of these tags come together to form a sort of hierarchy. So that is how HTML is parsed into something called a document object model. You have parents, and inside the parents, you have child nodes and all of that sort. The second step includes the creation of the CSS object model. CSS object model is similar to the DOM, but not the same. So, similar to the tree that we've created in the last part, we have styles associated with each of the nodes. Now, this styling is extracted from all your inline CSSs, from all your external CSS files, and all of that. So, it comes together to form the CSS object model. There are two things to it. It is script blocking and render blocking. By that, I mean that rendering cannot start unless the whole of the CSS object model has been finished creating. And that is why some of the CSS styles that occur later in the file override the ones that are above it. And the second part to it is it's script blocking. That means JavaScript cannot start running once this has finished creating. And the third part is the running of the JavaScript. So I would like to think like this. Say suppose you have to build a machine where HTML decide what all parts will that machine constitute. CSS will decide what will be the positions and the colors of all these parts, and the behavior and the dynamic aspect of the machine is stated by JavaScript. And that's what is done for our web pages as well. The dynamic content is always done by JavaScript. And the thing about JavaScript, it is parser blocking. By parser blocking, I mean is once JavaScript has started running, no more HTML can be parsed. And that is one of the reasons that you always attach your JS files after your body is complete, like towards the end of the body tag. And the fourth step is when the DOM and the CSS object model comes together to form something called a render tree. So we've seen that in DOM we just had the nodes, and CSS object we had styles associated with this node, and this comes all together to form our final render tree, which is to be shown on the web page. And the last part is generating layout and painting. So you've got your components, you've got your structuring, you've got your styles. So what next? Now, for all these structures, you have a certain size to it as specified by the CSS and as specified the content that is given in the HTML. Now, the browser decides what structure to be placed and what part of the page. So that is the generating layout. All the sizes are adjusted by the browser based on the available screen, the viewport screen, and finally these sizes are converted into pixels and painted out on our web browser. So far so good. There isn't anything wrong with this procedure. It works perfectly fine and it does the task pretty well. So where exactly is the problem? The problem is in something like this. So HTML is one of the person who does not care when something needs to be changed. He is given a markup, he is given a structuring of the page. Rest all, he does not care that anything needs to be changed. As I mentioned, JavaScript is responsible for the behavioral and dynamicity of your content. So anything that is to be changed in your markup, it just depends on JavaScript. So how JavaScript achieves that task is using something called the DOM APIs. I hope most of you must be familiar with these. Like these are the basic things we learn when we start with DOM manipulation with JavaScript. Your get element by IDs, your query selectors, you extract one of the nodes from the document object model and perform any of the computation. In change the inner HTML, you can add classes, you can remove classes, you can add children to it, and all of that sort. So the scenario is something like this. You have a rendered web page on the screen right now, and there comes an update that please update the username to maxcat243. Now, as I said, HTML is not taking responsibility for the same. JavaScript will have to do that changes. So it says update the username. He does that. And after some time, another update comes. It's like, okay, now update the points from 54 to 72. JavaScript is like, okay, I'll do that. And the last is change the color to blue to green. Now, as you see, there are a lot of changes that happen in your websites. And this is not the end of the update. There are more updates coming forward. A lot of updates may be occurring at the same time. A lot of updates may be occurring in 1 second and all of that sort. So it creates a lot of confusion because DOM APIs are expensive and time consuming for larger applications. So as and when our size of application starts to increase, calling these APIs again and again will really affect the speed of your application. It will be very time consuming, it will be expensive, and all of that sort. So the creator of the jQuery himself says the DOM is a mess. Now, by the DOM is a mess is not because the DOM is not doing the task properly. It is the inability of DOM to update things very quickly that is the problem, and not the DOM itself. So that's when a baby React comes into picture. So that is when I jumped into React and did not realize why are we using this and why are we not sticking to our vanilla HTML, CSS, and JavaScript. So as I said, I had to come back, read about it, and know what is happening. I went out to the React docs to find that there's something called the virtual DOM. So like, okay, virtual DOM. So as I read forward, the virtual DOM is an abstraction of the HTML DOM. I was like, okay, abstraction. So is it something like this? So as virtual DOM is similar to your real DOM, but not exactly the same. So it's kind of an abstraction of your real DOM, which is created as I shown in the previous slides. So this is something like this. So the overall picture that I got after reading a few things is you have a real DOM, you have a virtual DOM, and what React does is for any updates that take place, it is first reflected in the virtual DOM because virtual DOM is can be easily manipulated. It is not that expensive, and when a certain number of updates have been done on this virtual DOM, all of these are batched together to the real DOM, and it takes less number of times as compared to simultaneously updating the real DOM. So just to give you a code overview of this, say suppose you have, this is a basic functional component in your React. You return the HTML part, so it's called JSX. You have a div, you have a class name to it, you have some kind of children, hey, hello, then you have a button. Now what React does is change into something called a React element. The React docs says React element is a light, stateless, immutable virtual representation of the DOM element. So that's why the blocks started to stack upon each other because it says it's the representation of a DOM element. So you can think it's the basic unit of your virtual DOM. So you had a div. How React create element is made is you have a div followed by the class name and all the children. So hey hello was the text between your div, and then you have another component button. So you do another create element for the button. And when all of these React elements come together, they form something like the virtual DOM. All of these are compiled to form the virtual DOM. And that's where things started to fall into place, because I realized that it is actually a JavaScript object, and JavaScript object can be easily manipulated. So that is what happens. That is why React has adopted these virtual DOM to have uh, much quicker updates and to increase the performance. So to give a gist of all the things, this is your real DOM. You have a virtual DOM, which is the abstraction of the same. You have two copies of the same. And when anything in your app changes, it is reflected in one of your virtual DOMs. And after some time, these two virtual DOMs are compared or diffed, which is called diffing, and you get a patch which is then reflected on the real DOM. So that is how things happen in the background. So reconciliation is nothing but a sequence of steps that React adopts to make minimum number of updates to the real DOM and increase the efficiency. Now to just give you a quick overview, up till React 15, we used something called the React stack, and and in the newer version, that is React 16, the React team refactored the whole of the code and came out with something else with a new reconciliation algorithm called the React Fiber. So React stack used recursion, that is breadth first search, to travel between the DOM, whereas in Fiber you don't really use recursion. You save the parent-child relationships in a form of a linked list, and which is easier to break your work into chunks and reschedule and all of that. I'm not going to go into depth of that. I have attached a video. Lynn Clark gave a talk in a conference and she explained it very well. So you need to look this up. She explained it very well of all the videos that I've come across. So it was not just virtual DOM that React had to offer. There were many other things. Reusability. So what we did in our HTML was copy pasting again and again when we wanted to use some kind of components. However, React, adopted modularity where you can reuse your components that have been created once in any part of the code. Your abstraction where you don't need to worry about how things are being done in the background. It was very declarative. And the last part was states and props. So inside your functional components you have states and props where you can perform your logic, you can pass data from parent to child and all of that sort. But I still think we are missing out on something. And what is that? That was the React community. And by the React community, I mean both the React core team that works on the whole updation of the React and the React communities at different countries, different cities all around the world, React Bangalore, for example. And how these two play a role is very important. For React core team, they constantly update the whole structuring of the React application such that it increases the developer experience to next level. And how the React community like React Bangalore helps all of us indeed is by organizing these meetups where, for example, I am coming forward telling my mistakes that I've done so that somebody who's going through the same course does not repeat these kind of mistakes. And while I am attending, I get to know a lot of things from a lot of my seniors, from my juniors, from my peers, and it's a very good way to interact. So to give you a little bit of background, React was open sourced in 2013 at the JSConf US. Initially, what React used was something called the create class API. So at that time, there was no idea of JavaScript classes. So React had to create its own API to create classes within React. However, in 2015, JavaScript classes were finally introduced. And now React had two alternatives: to continue using create class APIs or to adopt JavaScript classes. And React chose the latter. And I think that was a very good decision at the part of React because that way we were more closer to the core JavaScript. We were not doing two different things, one at React and one in JavaScript. So we were a lot more closer to how things work in JavaScript as compared to React. So when the JavaScript classes came into picture, this is what our code looked like, where you have a class and you extend the React component, you have a constructor, you use super on it to declare this, and you use the states inside this. And you also had to do something called the auto-binding. So for any of the functions that are to be used in your React component, you had to explicitly bind those functions within your constructor. And if you fail to do so, you would get this very famous error. I have got this so many times unless I knew the workaround with this. And it was kind of irritating at first because there were so many functions that I was trying to use in my component and I had to explicitly bind all of those in my class app. But as I said, soon enough, class fields and ES6 was introduced. It saved us all. We don't need to explicitly use constructor if you're using your states, and we don't need to bind this. So after this addition to this, our component looks something like this. So you import React from React, you have your class where you extend your component. Since we are using your state, and class fields allow the state to behave as properties of your classes, so you don't need your constructor, you can use state like this. And what ES6 does is you don't need to auto bind your functions anymore, because you don't need to explicitly tell, okay, the this of the class is what is supposed to be used inside the function. The fat arrow functions handles it all, and whatever is your structuring here, it is rendered. So we were quite happy because as compared to the previous version, this code looked a lot of cleaner and a lot of simpler for us to understand. We didn't have to use a lot of useless things in our code that is monotonous and that are repeating again and again. So we were quite happy. However, there were a lot other problems with some other things as well. And it was something like this. So initially, like React has these life cycle methods where you have a method for everything, like component did mount when the first time the component is mounted, and when the component has been updated. So all of these functions get triggered on these life cycles of your React component. And if you see it closely, you would see some sort of a duplicacy in all these three things. By duplicacy, I mean this is our update repos. So we are passing an ID and we are keeping it in sync with the props. So if you see this update repos is being called again and again in these two life cycle methods. So there was a sort of duplicacy. There was nothing wrong in this. All we had to do is write uh, a number of lines of code extra. But picture this, when you have say 3-4 components which kind of is based on a similar kind of approach, when you need to write a lot of lifecycle methods like these, it will bug you a little because you're writing the same thing again and again and again. So there was a sort of duplicacy. And that's when the React core team, someone called Sebastian, uh, came forward with a gist saying, Ki, what if we have a function, and to that function we pass, say, some component, and for the component we perform all the logic that was being repeated, something like this. And in the end, what we return is the original component that was passed with all of our logic here. So if any other component other than this wants to use a similar kind of logic, what it can do is call this function, and it will return all the non-visual logic or stateful logic. So basically this was a logic which was preserved at one point. It was kept in a box, and whenever we had to use this kind of logic, we could just take out this thing from the box and give it to a component. We don't need to explicitly write all these things because it is preserved at one place for us. It worked perfectly fine. So you had a component, you passed it to a higher order component, and what you got was an enhanced composed component with added functionality, all the logic that was repeating. However, there is one problem with this, and that was the wrapper help. Now picture this, you have a component and you want to use some kind of logic which is spread across a lot of higher order components. Say there are 3 boxes kept in front of you, and you as a component want to use all the logic that is kept in all these 3 boxes. And for that, you need to wrap these components around all the higher order components. Now, this will create a lot of confusion for a person who will see this for the first time. It will create confusion for you as well, because here things are getting a little bit complicated and it is not at all flexible. There's a difference between modularity and flexible. So this was not flexible. This was something very weird. And here we're just using 3 higher order components. What if there are 4, there are 5, and so on. So this was a very big problem. So what we wanted was something which was simple and something which did not have this wrapper help problem where things start to get complicated. Something which is composable, similar to higher order components, so that we can add on our functionalities to a component without explicitly writing it again and again. And the third part was something which is flexible. And flexible by we can go and change whatever we need to change it in minimum number of steps. And that's when our dear friend React Hooks API comes into picture. While there was so much hype around React Hooks when it got released, all I could understand was this hype because we can use states within our functional components, which we were not allowed in the first place. But after reading these things, after going through some resources which told this kind of a backstory, it made a lot of sense. It it gave me a lot of closure of why we are resorting to this technique as compared to others, and where do I actually need to use React hooks. So the work that React hooks did was using state inside a functional components. So for that you have the use state hooks. So initially we were not allowed to use our states, and that's why I always used to resort to class functions wherever I had some logic that was concerned with states. And with this, our code became a lot of cleaner. We started embracing functions. We had the use state hook, and there was a better code reuse. By better code reuse, I mean the duplicacy that we had in our lifecycle methods was again solved with the use effect hook. So you pass a set of dependencies to the use effect, and when any of those things change, it automatically runs that function. So if like we said in React did mount and React did update, that whenever the first time it was mounting and whenever it was updating, we were simply doing the same task. But with React, with use effect hook, it became a lot of simpler, so that you pass your ID, and whenever it is changing in any part of your code, it just runs that code. So you had better code reuse, and also similar to high order components where you can add in your custom non-visual logic, you had the ability to create customizable hooks. And customizable hook, you can place all your logic inside this, all your use state and use effect hooks in this, and you can use that hook anywhere in a part of your code. So while the major hype was around using states inside of functional components, there was a lot more with that React Hooks API had to offer. And that was my whole idea of giving this talk, to make you realize, understand the backstory, understand why certain things exist, and understand what problem does it solve to be able to use it in a proper way. Otherwise, you can't just go on use some functionality without knowing where actually it is meant to be. So yeah, that was about it. Thank you.